Now this one, verify if the functions satisfy the ODE or not. So there's actually two functions now. We've got y double prime minus 2y prime plus y is equal to 0. And our first function here is y subscript 1 of x equals e to the x, and y subscript 2 of x equals x times e to the x. So we're going to actually check both of these. And in general, there's going to be more than one solution to a differential equation. So if it's a second order, it's going to have 2. If it's third order, it's going to have 3. And these are also fundamentally different from each other, right? There's no way to turn e to the x into x e to the x with a constant. So we'll see if this works out. So what I'm going to do here is I have y sub 1 of x. Well, that's e to the x. I'm going to compute all my derivatives first. I have y1 prime of x. Well, that derivative is e to the x still. And same thing with y1 double prime of x. That's e to the x. And I'll just go ahead, let's check it now. So I have, essentially I'm plugging into the differential equation. I want to check if y1 double prime minus 2y1 prime plus y1, is that equal to 0? All right, and I can just plug them in directly from here. So y1 double prime is e to the x, minus 2y1 prime is e to the x, plus y1 e to the x. And yeah, actually that will cancel. I have 1 here, I have subtracting 2 here, I add another one, so that is equal to 0. So that function works. Same thing for y2, it's going to be a little more annoying because of a product rule. So y2 of x is x e to the x. y2 prime of x, well, okay, I have to take the derivative, it's going to be a product rule. I'll take the x term first, that'll be 1 times e to the x. And then I have a plus. So then the other half is I take the non-derivative of x and I do times the derivative of e to the x. Derivative e to the x is e to the x. It's always a good idea to simplify these as you go. So instead of writing e to the x plus x e to the x, I can write this as 1 plus x e to the x. It can help a little bit because the number of derivatives you have to take decreases just a little bit. Right, and then I also need y2 double prime of x. Okay, well I take the derivative of the first term, well that ends up being 0 plus 1 e to the x, plus leave the first term alone, so 1 plus x, and then derivative of e to the x is e to the x. We can simplify that a bit. So we have a 1 e to the x here, we have another 1 times e to the x here, and a plus x. That all simplifies to 2 plus x e to the x. Now we get to plug this one in. So now we have y sub 2 double prime minus 2y sub 2 prime plus y sub 2. We want to know, is that really equal to 0? That's a terrible question mark. Okay. So let's plug it in. So y2 double prime, that's 2 plus x times e to the x. 2 plus x e to the x. Got a minus 2 times y2 prime. Well, that's 1 plus x e to the x. Okay. And then I've got my plus y2, which is just x e to the x. And still not clear if that equals 0. So we're going to have to simplify here. So let's see, I have, everything is going to have e to the x on it. So let me just put that in. And let's just start putting in terms. So what do I got here? I've got a plus x. I have a minus 2x from the middle. And then I have a x from the front. And let's see, then I've got a 2 from the front. We've got a minus 2 times 1, so minus 2, and there's nothing there. So yeah, that actually looks like it works out. So I had 2 minus 2, and then I have an x minus 2x plus x. And so yeah, it all cancels out. This is true. This actually solves the differential equation.